All right, go ahead, Gautam.
Awesome. Yeah. First of all, quick introduction. So I'm Gautam Dhameja, a solutions architect with Parity, mostly working on enterprise projects with customers and collaborators and so on. And and today in this seminar, I'm going to talk about and share with you is there are some samples, some sample pallets that I built in the last few weeks, primarily into the area of permissioning. Now, these are basically you can say useful for permissioned private networks, also for public permission networks as well. So the couple of palettes that I've built, one is account level permissioning. Joshi asked me not to use the term whitelisting, so I'll not use it. And the second one is validator set permissioning. So I'll give you a bit of a overview of what these are. So the first one, account set, is more about actually filtering out the or creating a list of accounts which can be used to send extrinsics to the node, and primarily useful in scenarios, in enterprise scenarios where we already have the user set who is going to make calls to the substrate or blockchain node, and other users are not allowed to actually send transactions, just to reduce the spam, to create more strong permission sets over there, and so on. So the transactions coming from or signed from these accounts will only be included in the validator, or how should I say, the transaction queue. And if they are not signed by these accounts, they will be removed even before going to the transaction queue. So that reduces a lot of spam and DDoS attack scenarios over there. The second palette, which I'm going to talk about, is validator set. So that is, I think, already pretty popular with Parity Ethereum client. So back in the days when Parity Ethereum client was being used in a lot of enterprises, it is still today. There is this smart contract, and along with that, which is called a validator set smart contract. What it does, it allows you to add new validators at runtime. So if you have a proof of authority network and you want to add new validators while the chain is still running, you do not have to go back and change the Genesis config or the chain spec. All you need to do is call this a smart contract, sign the transactions with the new validator's ID, and that's it. The validator will be added to the network. Now, you can put governance on top of it, like you can have a collective-based governance where multiple people can vote on a proposal and then the transaction goes through. Or you can have a pseudo-based governance where just one god comes in and makes the transaction go through. So there can be multiple ways of doing governance on this. But yeah, these are the two palettes that I'll be showing in this call today. And before we go further into code, feel free to ask me if you have any questions at this time.
Well, I wanted to just clarify something, because I've actually looked at the code and you said something that I hadn't fully internalized before, which sounds really cool. So there's this one palette that you said is for like account permissioning. So that basically just means like not even the validators, just like the users or transactors, I guess.
Yeah.
And you mentioned, so I realized before that meant, like if I'm not on the approved list of people to use this blockchain, then my transactions can't go through. That I think that's right, and I understood before. But what I didn't realize that you just said is, like, if I try to use the transaction, my transaction won't even make it past the transaction pool. It doesn't like get included and finalized and just not do anything. It like actually won't even be able to get in there at all.
Yeah. Yeah, so that's the fundamental difference between how we do it on smart contracts on Ethereum and how we can actually do it on Substrate. So when it goes through a smart contract on Ethereum, it has to go through the transaction queue. It has to go through the smart contracts storage. And there the check is made whether the account is part of this list or not. And if not, then the smart contract would reject it without making any changes to the state. In Substrate, however, because it's modular and amazing, we can actually just put this validation right there in the transaction queue using the SignedExtension trait, and it doesn't have to go through all the checks and balances and everything which smart contracts generally do. So yeah, that's a much you can say healthier optimization over there between the two approaches.
Yeah. Yeah, at first I was thinking of a technique that like sounds pretty similar to what you were saying what you would do in a smart contract on Ethereum. Like I was thinking you just do, like ensure signed and then check if the signer was part of this particular list, which I think that would work, but it sounds like not nearly as ideal as what you're describing here, where those transactions don't even go around for consensus or anything.
Yeah, exactly. So this is something that I would say that a few months ago I was trying to find this a solution for this, and that's when Gav actually suggested that why don't you use the signed extension instead of going through the extrinsics, and that's how I ended up with this solution. There was another way of doing it. There is a runtime API which is called Validate Transaction, which can already be used, but you can say because signed extensions were introduced in like this recent build that we have right now after 1.0, we thought that that will be a more optimized approach, a more, you can say, clean approach to do it. Otherwise, you will have to override the validate function altogether.
Yeah, cool.
Okay, cool. So should we get into the code, Joshi?
Yeah, that sounds fine. Yeah, for sure. Does anybody like want to throw out a question or anything, or like do people feel like they understand what Gautam's about to show us?
Yeah, I think so. I mean, the one thought I had was, as you know, I'm kind of interested in some of these like DeFi use cases. So like, I mean, it could be something where it's like a KYC or AML. Like if you want to set up a system like that, you could say maybe people that pass certain like business logic then like end up in this list, right? And then anyone else who tries to come in and use the system would just not even be able to spam your system, right? Or you'd be protected.
Absolutely, yeah. That's one more of the use cases. Sure.
Yeah, that's cool. I didn't even think of that. Nice. Okay, yeah, let's give it a go, Gautam. Do you want to like share your screen, I guess?
Okay, so I'll first go with the account set because this is the simpler one of the two. Okay, so so this is like a standalone pallet. It's not like part of a runtime already. It's being made as a separate substrate pallet, and it's essentially a Rust crate. I literally did it right from scratch, like cargo, new, minus minus lib, and so on. So, and then the first thing that I did was basically added a bunch of dependencies from Substrate because they are primarily needed for all of the pallets that we need to build. And so these are like the basic dependencies that we have from the Substrate side. Primarily, all of them are from frame system. Like if you can see, these are frame support, and then SP, the pallet support system, and so on. And then the only thing that is there in this particular pallet is basically inside the code is importantly the signed extension trait. So there is an implementation of signed extension. So what we do here is
Hey, Gautam, before you even dive into like what makes this palette unique, I wanted to just call out like I think this is a really cool repository structure. So this repo, I could, I guess compile it, but there isn't really anything I could run all by itself here, right? Like this is not a Substrate node.
Yeah.
It's just the palette. And then I guess in a little bit you're going to show us that this like is included in a separate node, right?
Yes. Yeah.
Yeah, cool. I think that's a really cool pattern that like hopefully we'll start to adopt it.
And I just had a quick question too. So I mean, I've worked just with the like node template before, which already has a bunch of stuff in it. And so when you were looking at the TOML file that had the includes, you kind of like work backwards to figure out what to put there. So it's like you, depending on what you're doing, then you figure out like the things you have to pull in.
Yes, exactly. So there are a bunch of includes which are needed for all these macro imports, which is the frame support side of things. And then we need a few more with respect to, you can say, the signed extension, the basic runtime stuff, the traits, and so on. So we just need to find out what exactly we need here. And a lot of these references are already there in the Substrate code, so I did not have to do a lot of digging. If I go into Substrate palette, which is like the palette from the Substrate framework itself, and I search for signed extension, I would just know what exactly do I need to import in here.
I see. So basically, this is the kind of structure you would use if you want to make your own frame palette, basically. I mean, you wouldn't start with a node template, obviously. You just start with as you said, kind of a lib project, I guess, then this would make something that would be includable then into like a project that uses a node template, something like this.
Absolutely, and that's what we'll look at in a minute.
And Gautam described the sort of like hardcore way to do it, where you start with like cargo new. We also have I think it's called the pallet template in Substrate Developer Hub org, which I assume looks really similar to this. So I can drop that link too.
Yes, yes, that also it's very similar. It actually already gives you a lot of imports that I mentioned in the tobble file. It already has a few of them, which will give you the initial bootstrap. For a few others which are needed as per the you can say functionality that you want to implement, you will have to import extra. But yeah, definitely recommend using the pallet template instead of going cargo new, because it already has a lot of things for you.
Do you mind explaining what SignedExtension trait is?
Yes, I am going into that right now. Okay, so so basically, what SignedExtension essentially is, and why we are using it here is because you can actually have so these are more like, you can say, validation middlewares before you finally go into the transaction queue. So when a transaction comes in, it can go. The first thing that happens, the node validates it whether it is as per the rules of this particular network, and there will be so. Actually, I should right away show you an example on how this looks. So on my screen right now, let me actually open the Substrate permissioning sample, which was posted as a link before. So this is the node template. And what I have here is inside the runtime, if I go into lib.rs, and I should actually zoom in a little bit, I believe. Yeah. Is it okay now?
It was okay before,
yeah.
But yeah.
So what I have here is right down here, there's a bunch of, you can say, signed extensions listed. So every new transaction that comes into this particular node and other nodes connected to this network, they will have to go through all these checks before they can be included into the transaction queue. So for example, the first thing will be checked is like if the extrinsic version is correct or not. If we are not using the extrinsic version that is there in the runtime, it will be rejected. Then we might want to check a few things about the genesis, then the era and nonce and wait, like what's the nonce of this particular transaction, do we have a wait for this transaction or not, and so on. Finally, there will be a check about the payment, if we are able to take the payment for this transaction. And finally, if you can see here, this is the custom signed extension that is coming from my pallet, which is like the account set pallet, which has a whitelist account signed extension. And this is also addressed. So now I'm going back to show you what exactly has been implemented in here, and then why it is added to this list. So if I go back to the code of the pallet, here I have a, first of all, when we start implementing the signed extension trait, we start with struct, basically empty struct, which and because I think, if I'm not forgetting it, there was a need to add these two trait bounds, send and sync, because of some threading related stuff. Because I think these validations are done in parallel or something, so on, but I'll have to double check on that. Then the next thing is we have to implement these debug functions for the struct, because they are needed by the framework. And finally, when we implement the signed extension trait for our struct, that's where we are implementing the validate function. So before implementing so here we have this validate function, which will be run on the transaction. And that's where we'll be doing the business logic stuff. But before that, we'll have to go through and implement a few types, or you can say define a few types for this particular struct. So what is our account ID in the runtime? What's like, now I'm not using this type, so I've just left it as blank, but in some of the other pallets it is being used. Then we have a few other things or a few other types implemented, and these are necessary. These are types that are needed for this particular trait to work. Finally, we go into and this is again the additional signed function. Again, we just have a we don't have any additionally signed information for this particular transaction, so it's just a default implementation of this function. And finally, we go into the most important part of this this particular trait is the validate function here. So what we have here is that every time a new transaction comes in, it will go into this validate function. Now, the who part will give us the account ID of the user who is sending it. The second part, and then call and length, we are not using in this particular thing. Then there is a dispatch info coming along with the transaction. And finally, the self is the extrinsic itself. Now, or the self is actually this struct, sorry. And this will have our types, which we defined above. So now what we are doing here is inside this function is a very simple check. We are holding a list of accounts, and this list is just right here in this pallet itself. If I go above and look into the declare storage of this particular pallet, I have this simple map of account IDs to bool. And this is what we are actually maintaining as a whitelist. If the account is in there, it will be allowed to go through and have its extrinsic submitted to the transaction queue. If it is not in there, then it will be rejected. So what we are doing in the validate function is exactly this thing. We just check if it exists in the whitelist account or not. If it does, then we are returning an OK transaction with the default parameters. And if it doesn't exist, then we are just returning as an error. So this is the, you can say, like I really call it the beauty of Substrate, that you are able to actually implement a validation queue, transaction queue validation in 10 lines of code. This is really cool stuff. So now how we are using it here is that, wait, before that, I actually should go into and show you one more thing. Now, you must be thinking that if when I start the node, if there is no account added, then nobody will be able to do any transactions to the node. So how do we start with it? So the first thing that we do is we give it a config. So our whitelist account storage map is also part of the Genesis config. So we can initially bootstrap with it with some accounts already. And that's what I will show you in the demo later in this call. And the other way of adding more accounts to it is through a sudo permission. So I have in this exact pallet inside the declare module, I have two extrinsics defined here. One is add account and the other one is remove account. So the names are very self-explanatory. What we are doing here is we are simply, if the origin is root, then we are simply inserting the account ID into our storage map. And similarly in the remove one, we are just removing it. So there are two ways to actually add and remove accounts from this palette, the Genesis config and then extrinsics. So that's more or less about what has been implemented. There are a couple of events to show if the account was added.
Hey, Tom, I've got a question about the storage items, and I wondered this when I was first looking at the code too. So I definitely understand you're like maintaining this set of people or accounts that can submit transactions. What's up with the mapping to bool? Like, what does the bool mean?
Sure. So this is only for the reason of doing an exist, because if I just do a vec of accounts, then I cannot do an exist. I'll have to loop through it and check whether something is there or not. So just to do an exist on a list of items, I had to go with a mapping. Now the bool is just a placeholder. We tried a couple of different things. I think there was a discussion in public where Joshi, you asked a question. We could have used the empty type like this thing.
Yeah.
But that didn't work because of Genesis config. Because Genesis config, when you bootstrap it from there, it needs real types to be added. So it was not reading these values. So we had to go through with account ID to bool to have a exist kind of functionality on a list.
Okay, cool. So the bool, so like you wanted a map so that you can just do this really fast. Does the thing exist? You didn't really have anything to map to, so you just chose a simple type like bool. So
Absolutely.
like, okay, it's not the case that like true means I'm in the list and false means I'm out of the list. It's like, if I'm in the list at all, I'm mapped to true. No one's ever mapped to false. And if I'm not in the list, I'm not in that map at all.
Exactly. Other way of doing this, I mean, that wouldn't work actually. So everything, so essentially in a map, every possible account ID is already mapped to false. When we are inserting something, it is already, then we are changing it to true. So if you query this map that there is a particular account ID or not, then if it is, until it is true, it is not there. If it is false, then it is already there. So that's like how maps work basically. So it already has all the possible account IDs in it. All we are doing is just replacing the false with the true when we are adding something.
One doubt. So why do you use why didn't you use a kind of blacklist accounts, like we have a certification revocation list in, like I work in Hyperledger, so we have certification revocation list. So we search for the accounts who are revoked. So in this, like if we have more than like 500 accounts, we have to put all 500 accounts. So it's better to put those accounts, like those who we want to blacklist. So why don't you went with that approach?
Well, just a personal preference, because I actually added it here that we can have it as a blacklist as well in the README. So it will just be a reverse of the logic, right? If you want to have a blacklist, you will just see that it should not be existing in it. Then that's it basically. So I think it's just a personal preference. It's all I wanted to show with this palette was how straightforward and easy it is to create a validation queue transaction queue validation, and then you can do absolutely anything in it. I'm actually working on another palette for which I got my PR merged in Substrate today, and I'll be able to use it to create more lengthy validations for transaction queue. So yeah, it's just a matter of preference.
Okay, I thought there will be some like big technical thing that's why I chose this path.
Yeah. Cool.
I had a quick question as well. There was like the config call, I guess, that was in decal storage, like against the map. I just wanted to make sure I understood that. It was, on the GitHub side. Yeah, if you go to.
So that was basically making sure, marking this particular map as part of Genesis config.
So that means then if I just had some initial state I wanted to specify for this data structure, I would put it in, it's part of the chain spec and all of this, like.
Exactly. So if I go back to my sample here in the chain spec, if I go down here, then this is my palette, and this has Alice and Bob in it already. So this is how, once I have marked it as config in the storage storage map, then I can actually set values over here.
So that's true of, I guess, any data storage item, you can do the same thing, I guess?
Absolutely, yeah. I mean, whatever is supported by the declare storage macro.
Got it.
Yeah.
Thanks.
Cool. Any other questions? No. Okay. So let's do a demo. So let's see this one first. So what I'll do is I'll just start my node in dev mode. Cool. So it has started producing blocks. I think I should be able to zoom into this thing as well. Cool. So my node is now running. Let's go to Polkadot apps portal. Where is my plus button here? Okay. So there we go. We have our node running, and the Polkadot apps portal should be connected to it first. So local node, and then okay. So let's first of all see who are the allowed accounts in this one. So I think these are just Alice and Bob here in my Genesis config of this particular account set palette, right? So if I send a transaction from Alice and Bob, it will be included. So let's Alice, and let's do something. And this is applicable across all palettes. So if I do any palette, basically like the template module here, Let's save a number from Alice's account. It will go through. So it went through and we have the transaction extrinsic success over here. Now let's try something from any other account. Let's try something from Charlie. So if I go and do exactly the same extrinsic from Charlie's account, it will give me an error. It will simply say that, oh, first of all, I have to fix the Charlie's payment error because Charlie does not have any funds. So he actually failed the previous signed extension. So if you remember, there are a bunch of signed extensions we have. So Charlie just failed this one because it did not have any funds. But let's give him some funds and then let him fail on this one as well. So let's give some funds to Charlie and.
So your signed extension applies here too. Like if Alice weren't in the approved list, she wouldn't even be able to transfer funds to Charlie.
Exactly. Yeah.
Luckily she is, I guess, so she can share those tokens.
Yeah. Okay. So now Charlie has some funds. Now let's try with Charlie's account again. So now it fails. It gives me an invalid transaction with the call, and this is exactly the error that I had in my pallet. So if I go here and if I go into the validation, it gives me an invalid transaction of the type call. Now, if I want to allow Charlie to actually do some transactions on the chain, all I have to do is go here and use the Alice account because that's my root account. So if you go back to chain spec over here, in the dev mode, the root account is Alice. So I have to go through Alice this time to add Charlie to the list, to the whitelist basically. So I have to go through sudo, do a proposal on account set, and then I have to choose this add account function over here. And then in the account ID, I want to use Charlie. So when I submit this particular transaction, and when it finalizes, Charlie will be added to the whitelist. So it happened. And then the account set palette also created an event, account whitelisted, and a few other things. So now if I select Charlie and try to do anything absolutely like template module and do something, and this is the transaction that failed previously. If I try to do it now, it should go through. So it did. Now, this is how basically the account set works. It basically you can add accounts on the runtime and then allow them to transact on node. And this is applicable across the whole runtime because it's in the validation queue itself or transaction queue itself. Why do I keep saying validation queue all the time?
So
anyway,
Tom, I've got a question. In this case, when you went to add Charlie to the approved accounts, and it wasn't like Alice did that herself just because she was already in there. That was a pseudo call you made, right?
Yeah.
So if we, if you imagine using something like this on a bigger chain than just our dev one, like you could imagine maybe wanting some more complex governance. Like, is it easy to, I don't know, well, like if I wanted to use a console or something like that, how
yes. Okay. Yes, I am actually planning to add council to the permissioning sample, and all we have to do over there is actually use the custom origin that council has. So it has a bunch of custom origins: ensure member, ensure members, and so on. So ensure member is basically like if it is a member of a council or not. So that will be like multiple pseudo situations, and ensure members. It's basically a threshold condition where we have something like a DAO where we can say that 4 out of 5 people voted or multisig kind of thing. So all we have to do is instead of using ensure root, we have to use ensure members when it comes to council. And that's it basically. Yeah. So this was account set, very plain and simple, straightforward, just to showcase how signed extension works. And simple whitelisting. Now let's go into the validator set stuff. I can pause for a second if there are any questions. Cool. So let's get into this one. So again, now this is exactly the same, you can say, directory structure because this is again a standalone pallet. In addition to the imports that we saw previously, this has only one additional import, which is the session module. And I'll go a little deep into that, what exactly is session module, why we have it, and so on. So in Substrate, what we have is basically, how should I do that? Should I draw something on my screen? Maybe that would be better, I think, yeah. Okay, so what happens in Substrate is basically that we have multiple pallets. So at the right bottom, and take this thing as a pinch of salt, with a pinch of salt, because I might not be completely correct on this thing, but I am partially correct, I know. So, so at the very bottom, we have these consensus layers. So we have Aura, Grandpa, Babe, and more in the future. So what exactly happens is that all of these nodes, they have, you can say in a particular network, whether it is proof of stake or proof of authority, we have a concept of validators, and these are the people generating blocks for the network. And in the only difference is that in Aura, it's more like an authority round kind of consensus. In Wave, it is I think it is fast forward or something like that, and Grandpa is there for finalization. But everybody, each of these consensus modules needs a set of validators for their functioning. Now, you can either give them a set of validators from the Genesis config, or you can give them from the session module. So on top of that, what sits is the session module. So here, right on the top, we have session. Now this module primarily is responsible for making sure that the validators are given to these consensus pallets. When they are changed, the required amount of events are raised, or required amount of, you can say, lambdas are executed to get the validator set changed, and so on. What happens in the Polkadot network is that there is another module on top of it, which is called staking, which is responsible for electing staking and fragment, basically, which is responsible for staking the dots from validators and then electing them. And I am really not sure what's the exact spelling of this thing, but this is a
Looks right.
and the funny part is the autocorrect tells me to name it as diaphragm, but I will not. So so this is how this looks like in Polkadot network. We have staking and fragment for electing, for putting the stake in the network, and then electing who have from the people who have put the stake as validators. Then we have session, maintaining the list of validators, making the required changes when it is needed, changing the session on the go. And session is basically a collection of blocks, and so on. And finally, at the bottom, we have Aura, Grandpa, Babe, taking their validators and doing their stuff. So this is how it looks like on Polkadot. What we did in this particular case, because I was trying to focus on something completely proof of authority. I didn't want staking or fragment or anything. Think of it as a network inside an enterprise, or multiple enterprises coming together. They don't want to play with staking or so on. They just want to add and remove validators as and when somebody new joins or somebody leaves. So what I did in this particular case, instead of using staking or fragment, I created a new pallet called Validator Set, which sits on top of session. Now, Validator Set, all it does is that it basically maintains a list of validator IDs and passes those validator IDs to the session module when there is a change. The session module then takes care of the rest. So this is exactly what I did in the Validator Set. And now, if there are no questions at this time, I'll go back into the code, but I think I should pause for a second for this to sink in. Feel free to ask me any questions. No? Okay. So going back to the validator set palette, like I mentioned that this depends upon the session module. So the trait that I have here also has the decoration of session module over here inside the palette. And then inside this, again, in the declare
Tom,
storage.
let's slow down on line 20 there for a second. This is something we haven't talked about very much in seminar. I think we have a time or two, but this is a cool thing that you don't see in a lot of palettes, right? Like every palette has pub trait, and it usually requires, it has that like colon system trait. What exactly does that mean, and what does it mean that you've added plus session trait?
So it essentially means that this particular palette will basically be, you can say, if you talk in terms of conventional programming languages, we have this concept of inheritance, that you can inherit the functionality of a parent class. This is something similar to that. You can inherit the functionality of session trait in here in this particular module. That's essentially what it means. That if I want to use the function of the session module, then I will have to decorate this thing with the session trait.
Nice. Yeah, I think of it even as like, yeah, or exactly like that. And then another way I think of it is like, if I want to use this palette that you're showing me here, I can't use it without session. Like it's going to interface with session. It only makes sense with session. And then like on line 20 there, we're sort of telling the type checker that like, don't compile this stuff unless the session palette's also there, because I'm going to call its APIs. And I've seen people do this before also, like, if I was building a pallet, I mean, seems like I'm always talking about gambling, but like if I was building a casino pallet and I wanted to be making wagers in, like, let's say the token that comes from the balances palette, I might do the same thing there. I might write like plus balances trait, and then it says, don't use this casino palette unless you also have the corresponding balances palette, so that we can.
Right. Yeah.
Cool.
Exactly.
Okay. Thanks.
Cool. So in the declare storage, what I have here is basically a set of account IDs, which will be, you can say, represented as validators. And there is a flag that I'm maintaining here, which I'll talk about it later. So the primary thing is this list of validators. This is just a simple vec of account IDs. Now, what I have implemented here as and then these are some events and errors, the normal stuff. So what I have in the declare module here is that there is a function called add validator and then a remove validator, which is basically just the opposite of each other. But what we do here is that, first of all, this is again a root origin. We can change it to collective and so on as per the need. First of all, what we do is, if there is a new validator being added, we just put it into the list of validators. Then what we do is tell the session module to rotate the session. Now there is something interesting going on in here, and I'll show you the session module in a second. Then we raise the event that validator has been added, and then we select the flag and put it to true. Now, this is again why I wanted to talk about the flag a little later, but this is essentially the flow. We added a new validator to the list. We rotated the session manually, because the session can be automatically rotated as well. And I'll show you that also happens. And then we just raised an event that a new validator has been added. And finally, we had to put a true in this flag. Now, what's exactly happening in there is that we have also implemented a bunch of traits from the session module. So first of all, the trait is should end session. Like, this is telling the session module, should the current session be ended or not. And that's why I was putting a true inside our flag, that if this returns a true, then the session module will end the session, take the new validators, and give those new validators to Aura, Grandpa, and whatever we are using down below. And that's why this flag is being maintained. Now, there is another trait called session manager, which is basically telling us what should we do when a new session happens and what should we do when a session ends. Now, when a session ends, we don't want to do much, but what we want to do when a new session happens is that we want to, first of all, return the set of validators that we have, the new validators, because we have added a new one or we might have removed an old one and so on. And we want to set the flag to false at this time, because otherwise it will just keep on rotating the session. So how it works is that I should actually go into the code and show you that, that thing. So if I go into Substrate code and go to the session palette, session, there it is. And exactly here. So inside the session palette, on the initialize function, it just checks if there is a pallet sending should end session, then it should just do a rotate session right here. So if we keep on returning true from our flag, it will continue to rotate the session on every block, because this is happening on every block. So we have, as soon as the session has been rotated successfully, we will have to set the flag to false. And that's the only need for our flag, to make sure that the session is not being rotated unnecessarily. Now going back to my validator set palette over here, I believe. No, it is on GitHub. Yeah, here. There is another one, basically a simple trait implementation, which is validator of. This is a struct, and then we have implemented a convert. Now, in some networks, like especially I think in the Substrate node and the Polkadot network, there is a different mapping between validator ID and account ID. But for this particular simpler implementation, what I've done is simply kept them the same. So account ID and a validator ID can be exactly the same. What matters is basically the session keys, and I'll come to that later. But here it's a simple conversion to give you the validator ID exactly as the account ID. In Polkadot, this is implemented by the staking trait, and it implements that in a slightly different way, because that's in that particular scenario we have the controller keys and stash keys or stash ID or so on. So then there's a mapping between controller and stash over there. But here it's just a simple account for POA networks. So going back to what's happening here is that if you can now see that, first of all, I'm doing a rotate session manually on this line 64, and then I'm putting my flag to true, which essentially will do rotate session again. So there is a question, why am I doing rotate session 2 times? So let me answer that. If I go back to Substrate here, and if I go to this rotate session function, what happens here is the first time when it is called with a change in validator IDs, like it will first of all get the valid. So first of all, it will get the new validators from here, like, or maybe actually not from here, but from yes, here. So if you remember, we had this session manager new session implemented in our palette, and it was returning the set of validators. So just to reconfirm, let's go back here and here. So session manager new session returns validators like this, right? Now in Substrate, it is taking these new validators and it is putting them in the queue. Next time when the rotate session is called, then they will come into effect. So that's why we are calling rotate session 2 times, because first time it only queues the next set of validators. The second time we want to put them into, you can say, the actual validator set of consensus and other places. Now there are some, so I was having a chat with some of our core devs on asking whether we can decouple this function into 2, so that one takes queues the validator and the second one actually ends the session and so on. But it seems like they are not still convinced. I will have to work hard on that. But this is the reason why we are calling it twice. First, we queue the new set of validators through calling the rotate session, and the second time we actually make them the validators. Does that make sense? Was I too fast on this one?
I think I mostly get it. So a session is basically just like a period of time where there's going to be some fixed validators for the entire session.
Yes.
And is every session the same amount of time?
Yes, the session length is in number of blocks, basically.
Okay. All right, cool.
But if we are ending, so the session length is generally in the number of blocks. But if we end it, you can say preemptively. Like in this case, when a new validator is added using the validator set palette, then we are actually ending the session manually. And then in that case, these session could be of different lengths, because we will add a validator and then we will go back to work, and then sometime later a new validator wants to join, then we'll end the session again. So this can be different.
Okay, I see. So yeah, so I think Gautam, you and I talked I don't know, a month ago or something. I had written some similar code, not as nice code, that I had showed on seminar, and like I kept having to just wait and wait and wait. Like my code kind of worked, but every time I inserted a new validator, it felt like I had to wait forever for them to take effect. And I guess it's because I didn't do what you have highlighted here, which is like, you know, end the session so that these new ones can, and especially end the session twice so that the new ones can come.
Yeah, this is exactly what I faced also. And then I had to sit with Guillaume, who is the co-dev on the session module right now. And he actually helped me understand this thing, that the rotate session is first doing the queuing, and the second time it is actually making them the validators.
Yeah. So is there like, it seems like there must be a reason why they came up with that logic to first do the queuing and everything. And I wonder, like, is there any danger in ending them early like we're doing here, or why did they do that design in the first place?
I think that was primarily for the purposes of staking and slashing, the way I understand it, because it takes some time for the new validator, before the old validators go away, they are slashed and so on. And then we want to have a little bit of, you can say, breathing time in there, so that the next ones, when they take effect, the old ones have already been slashed and they are done with them, with things, and then now the new ones have taken effect. So this is primarily for the reasons of staking and slashing. It has nothing to do with actually the session itself. It's more about the higher level modules.
Okay, yeah, I guess I can. I don't quite have my finger perfectly on it, but I get the big picture idea of like if I'm a staked validator and I'm always running the risk of getting my stake slashed if I misbehave or go offline or something, then maybe there should be like a slow unbonding period and all of that stuff. And here in proof of authority, that's totally irrelevant because these people aren't staked or anything anyway. They just like, you know, work for the company or got approved through some like interview process or something. It almost seems like that logic about queuing up the keys for a couple periods should be in the staking module instead of sessions, but maybe I don't know the code well enough to know if that's quite right.
Exactly that. That's what I was also thinking, that it should ideally be in a higher level module, but because it also relates to ending of a session. So it's kind of a gray line there. Like, should we keep it in staking or should we keep it in session and so on?
Cool. So, okay, I've got another question. So why did, like, if it's so easy to just manually trigger a new session like you did on line 64 there, then why aren't you doing that same exact thing, like, you know, twice? Or what's the purpose of using the flag to do it a different time, the next time?
I think I haven't tried that, Joshi, to be honest with you. So I had the flag initially, and then I was running into the exact same issue which you just described. The session was changing, but the validators were not changing.
Yeah.
And then I just put this line 64, like, let's do it manually, and then we'll see what happens. And then it just worked. And later on, when I figured out why is it working, then I saw that, oh, it's happening. It needs to happen twice. Now, there was a reason why I still kept the flag, and then I made it false in on session ending, because because this one was still being called from rotate session, and it takes the validators from here, and then it queues them, and then it has to come back again. Okay, yes. So if I don't call this particular on session, this new session stuff here, then I will not be able to return the validators back to the session module. So there was some reason. I know I'm not making sense right now, but there was definitely some reason for this.
Yeah, okay. So when a session ends like the normal way, not the you did it manually way, it always calls this trait that you're showing right now, and that's where it actually gets the validators back.
it will actually call it even if it does, even if it is done the not normal way, because ultimately that trait is being called from within rotate session.
Okay. Okay, cool.
So yeah,
Just a question.
Yeah, I guess I just had, and this is, I'm still learning Rust, so I just want to make sure I kind of understood, some of the more advanced Rust things I was seeing here. So, with these traits, is it correct to think, so they're kind of like an interface, I guess?
absolutely.
And so by marking this thing as having the session trait, you kind of get, I guess, pass through for free the implementations of all those interfaces from the session module. But then if you specify an implementation here, you're kind of overloading that one, and it's going to use whatever's in here versus whatever was in the thing that you're like pulling from. Is that the right way to think of it?
Yes.
And then you can use this palette anywhere that anywhere that needs kind of the session, all the interfaces that are on the session.
Yes. So it's basically a combination of traits and types over here, and I'll show you when I'm actually including this palette in the runtime. So first of all, your understanding is absolutely correct. Traits are actually just interfaces with a fancy name in Rust. And you can actually, but the most important thing is that you can put them on structs and I think types as well. While the interfaces in other languages are generally put only on classes, if I remember correctly. So that's one difference. But apart from that, they are just a way of putting bounds on a type.
So Derek's question reminded me there's actually a piece that we haven't seen yet, which is where you implement like the session trait and this pallet's trait when you're like building your whole runtime, right?
So that's what I was actually just coming to right after this. So here, this is substrate, but in my node template, when I'm actually describing these pallets for construct runtime, that's where I have this defined. So this took some time actually to figure out. So here I'm implementing the session, and then if you see should end session is set to validator set. In Polkadot and in Substrate node, it is set to staking.
So this is like the implementation to use for this type, basically. Yeah.
So for this particular runtime, when I'm implementing session, I'm defining the types here, and
this would presumably give an error if validator set didn't implement the session trait, then you'd get some kind of checking error, basically.
Yes, there will be a compile error over here.
I understand.
And yeah, so validator set is basically coming from my implementation and include here. So here, that's the validator set, and that's for the session. Now there is one thing very important. I'm not sure if it has changed, but last year when I implemented exact same thing for Substrate 1.0, I had to make sure that session and validator set come before Aura and Grandpa in construct runtime. If I put them after, they will not be able to provide validators to these, and then I will not be able to start the node. I will still be able to compile it, but it will not start. It will say that there are empty validators for Aura and Grandpa. If I put them before them, then only they get the validators. Now, if you go to change-spec.rs over here, and if I go into the change spec, so in the validator set, I have some initial validators defined over here. In session, I have the exact same validator set with their session keys defined over here. So these are exactly the same validators with some additional config in session. However, if you go to Aura and Grandpa, they are now empty. If you clone a new node template, you will see values in Aura and Grandpa. But because we are using session and validator set in this one, we have to make sure that Aura and Grandpa are empty validators, like their validator set is empty, and it is being provided by session because it is there in the runtime, and the sessions validator set is provided by this particular validator set. So that's the hierarchy we have here, exactly the way I showed here in the diagram, that validator set will provide to session will provide to Aura and Grandpa. So does that make sense, first of all?
Yeah.
Yeah. Cool. So yeah, this is this is the config for this particular pallet, and then um, it's essentially just the configuration and or you can say instantiation in lib.rs with the right traits mapped to their particular things. Now, one thing is which is more important here is the session keys. I almost forgot about them, but going back here in my here, so in lib.rs, I have an implementation. So if you clone a plain vanilla node template, you will see these session keys exactly the same way, but they will have aura first and then grandpa. Because of some reason, while debugging, I just flipped them, but it doesn't really make a difference. What the difference that is there is essentially that they should be exactly in the same order all across. So if you see these keys are grandpa and aura like this, and if I go to changespec.rs, over here, there is a need for generating session keys. So then again, I have grandpa and aura being returned in that particular order. Then if I go down here in the change spec, actually, again, here I have grandpa and aura in that particular order. This is the account ID basically. I think I'm using it for some reason, the validator ID exactly. And then we have grandpa and aura. So this account ID is for the validator set. This is for grandpa, and this is for aura, like these three modules which need validators. And so that's the most important thing, that when you have session keys in your, and you will have session keys in your runtime, you have to have them in exactly the same order everywhere. Now, if you look at Substrate node, it has two more session keys associated with it, which we are not using in this particular sample. So just to give you a bit of a trivia on this thing, if I go to bin on the Substrate repository, and if I go to the runtime lib.rs, the session keys are 4 over here. So grandpa, babe, I am online, and authority discovery. These are 4 session keys being used in Node. However, in Node template, we do not use I am online and authority discovery because they are not needed in Node template. But here we are using the Babe consensus algorithm. In Node template, we use Aura. So that's the basic difference. But apart from that, it's the concept is pretty much the same.
Oh, so Gautam, this reminded me, like, the sessions palette itself is really abstracted over whatever kinds of keys it is that you're using. So like in your demo, you were using Aura and grandpa keys. Here it's using a lot more, and like, you know, I can imagine some hypothetical chain that uses proof of work for authoring, so wouldn't even have keys there, but maybe still like uses grandpa for finality or something. And seems like really not much other than those little details has to change about your validator set code.
Yeah, absolutely. There is one, however, thing which is actually being used by the node itself, which is this generate session keys. So it will then basically, when you pass a seed to it, it will generate session keys in return, and it will generate them exactly the way you have defined in the lib.rs. So this is a
what are we looking at here? Is this your runtime? Oh, this is the Substrate node runtime?
Yes. So this is exactly the same everywhere. So if I go to my runtime, then over here, if I go to lib.rs, there is a RPC, or how do we call it? A runtime API, right? So there is a runtime API defined, which generates the session keys as per what we have defined here. So if in this particular case, we have this session keys defined as inside this particular file, and then we call the generate function on this. And this is exactly what you have in author rotate keys, basically. So when you run the node and you go to the, so I think the node is already running over here, so I can just quickly show it. So if I go to this toolbox thing, and if I go to author rotate keys, this is exactly what's happening from this particular runtime API, this here.
Okay, this is a piece that I have not looked at before, or if I did, I just copied something and didn't understand it. So you're looking in your runtime file right now. So like if you scroll up, there's construct runtime up there, I guess. We're just below that. Okay. And
yeah.
This is a part of the code that I just started looking at that I have an upcoming seminar on. But every runtime implements all these runtime APIs, and like the first few I think are core ones that kind of all of them have, and then there's more that you can have depending on what your runtime does. And so you were just pointing at one that like a runtime API that you need to implement if you're using the sessions palette?
No. I'm just pointing out to that runtime API. We don't have to implement it. It's already there.
Oh.
It's already there as part of the template. I was just pointing it out that this is being used to generate the session keys, which we'll be needing when I'm showing you the demo in the next few minutes.
Okay. Can you show us that API again? So you're saying it was already there. You didn't like write it. It's just kind of relevant for what you're about to do.
Exactly. Yeah.
Okay. Okay. So it's called session keys, but it's not coupled with like the sessions palette.
No.
Okay.
It's basically coupled with your runtime.
Okay, I see. And so here's the piece that I really didn't understand. Like when you make that RPC call to your node to say like, hey node, generate me, like, rotate my keys, generate some new keys and let me use those now. Your node actually calls into the runtime and does that here with this function on 385.
Yes.
That's cool.
Otherwise the API wouldn't know what keys do I really have.
Oh, sure, right. Because like it doesn't know if you need babe keys or aura keys
Exactly.
or what combination. So that's why it has to call into the runtime to do that.
Exactly.
Oh, cool.
Yeah, I mean, I fully agree with you, Joshi. Like anything below construct runtime is kind of magic. And
We
I
did a
also-
seminar a few weeks ago where we added just like a, not very complicated one, but one that just like summed up 2 storage values. And that was the first time I sort of dived in down here.
Mhm. Interesting. Cool. So so this was validator set palette. I think there was one more question and we kind of interrupted that person. So first of all, we are sorry. And then now please ask your question. No? We missed the chance. Okay.
I got a question.
Yeah, go ahead.
I'm just trying to think of what's the real world application for this
Palette?
palette. Yeah.
So the real world application would be like Joshi mentioned, if you are in an enterprise and if there is a partner joining the network. You like my tweet thread today, right?
No. Oh wait, I did. Yeah.
Yes.
Yeah.
So I have mentioned that use case over there. So if a new partner wants to join a network and you want to make them a validator, then that's the use case essentially.
So that's similar to proof of authority.
Exactly, that's what it is. Yeah.
So what's the main differences between this one and the proof of authority one we went through earlier?
Which one?
Yeah.
So the first one was account permissioning. This one is validator permissioning.
Okay, I'm with you.
Yeah.
So the first thing you did is nothing to do with validators. It's just about straight up who can use the network. And then this one's about validators.
Okay, I'm with you now.
Yeah. So now that you say it that way, Joshi, it makes more sense. So first, who can use the network? The second, who can produce the blocks?
Yeah.
So like that first one, that account set one, we could have, I mean, this would be kind of a funny thing, but we could have like a proof of work network where block production is totally permissionless and literally anyone can do it, but only certain accounts can actually, make transactions with that first palette that you showed.
Yeah. Cool. So let's see a demo of this. So first of all, I'll run the node as Charlie, who is not a validator, because I want to connect this Charlie's node to Polkadot apps portal. Otherwise, I will not be able to call rotate keys and stuff, because the node which needs to be added as validator needs to generate keys and stuff. So let's do this. So first of all, let me show you the config, what I have here. I can close the Substrate repo now because it's really killing my laptop battery. So in the chain spec, if I go here, it has initial set of validators in it coming from this particular vector initial authorities, and what they are exactly here for the local testnet is this. So Alice and Bob are the 2 validators assigned in the validator set the chain spec, and they are the validator set config as well. Yeah. If I run the node with Alice and Bob, they will start to produce blocks. So let's do that. I have stored something here. So this is so what I'm doing here is, let me actually, when I paste it into the terminal, it will be bigger, and then I'll show you what exactly I'm doing. So here, if I go to this thing and first of all, target release, and then I paste that thing here. So what I'm doing here is that first of all, chain is local. It's not dev anymore. Alice is the validator ID, or you can say this is the seed that I'm giving, which will basically generate its validator account ID. Base path is different because if I run all the 3 nodes with the same base path, they will conflict. So I'll have to give them custom base path. And one more thing that I have to do is give them custom node as well. Oh, sorry, custom port as well. So let me copy that thing from my previous sample. What's happening now? Yeah. Okay. So substrate POA. Joshi, do you remember this one? We did this together last year, the POA stuff.
Yeah, I do. This ultimately turned into the tutorial that's still up called Start a Private Network.
Ah, okay. So I have to just copy this port for the 3 of them differently. So for Alice, let's say 331. For Bob, let's say 333, because I think 332 is being used somewhere. And then for Charlie, let's say 334. So we have 3 custom ports also defined now. So let's start with.
And this bit about the custom ports, this isn't like super closely related to the code you've shown. This is just so that you can have all these guys on the same physical machine without like stepping on each other's toes. And
yeah. And yeah, so like I mentioned, I want to run Charlie first because he is not a validator and he needs to connect to the Polkadot apps portal. So let's first run Charlie over here. And then so now Charlie is now on the local chain, and we'll wait here for a second and we'll see that no blocks are being produced because Charlie is not a validator and this is a local chain and we need at least 2 validators to do that. So as you can see, best 0, finalize 0, no blocks here. Now let's do Alice. So Alice is now started. They basically, but still there will be no blocks because we need at least 2 validators on the local chain. Now let's go. So now Alice has found it's paired Charlie as well, but still no blocks. Now let's go to Bob. So here in this, let me zoom in again. 1, 2. Okay. I'll have to. And then Bob. So before I start this one, just to reconfirm, there are, oh, Alice is producing blocks somehow. Yeah, but
maybe she just needs a peer, not a peer who's a validator.
I see. Okay.
I didn't know that, but it seems that way.
It seems that way. Yeah, exactly. But here, if you can see, Charlie is not producing any blocks. Charlie is only importing them. So this is only import. There is no proposal of any blocks. So Charlie is not a validator. Now let's run Bob in any case. So now we have 3 nodes running on the same machine, out of which 2 are validators. So this is Bob. It will first synchronize. So now it has best 7, imported 7, and now it will produce or propose something as well here. So if you see these kind of messages, that means the node is a validator, like it is preparing blocks and it is proposing for stuff. So now both Alice and Bob are producing blocks and Charlie, poor guy, is still just importing them. So let's make Charlie an equal. So let's go back to Polkadot apps portal here. And first of all, what we have to do is, because we have removed the chain state, because it is a local chain, we'll have to make Charlie someone who can actually send transactions, because this, remember this, this thing is still includes account set as well. So let's first of all make sure that Charlie is able to send transactions. So I'll do is,
so what transaction does Charlie need to send here?
He will have to set his session keys.
Oh yeah, well that's an RPC call though. Oh no, sorry, you have to do that in the sessions palette, right?
Exactly.
Okay, cool. Cool. Yeah, let me stop interrupting because there's a lot of steps here and I always get them confused.
Oh, actually keep doing that because otherwise I'll forget a lot of things.
Okay. All right, cool.
So let's add Charlie as a guy who can send transactions. Okay, so now Charlie is added to the whitelist. He can send transactions. Now, the first thing that we want to do here is go to the toolbox. And because this node is connected to Charlie, because we started Charlie first, we should be able to generate keys. So first of all, when we call this endpoint rotate keys, it will basically generate keys, session keys for Charlie. And this hex value is essentially, you can say, all the public keys together and then hex encoded basically. I'm not sure what are the essential details here, but this value needs to go into the session palette. So
somehow, I don't know the encoding or anything, but somehow that hex string represents his aura key and his grandpa key, I think, right?
Public keys, yes. Yeah.
Okay. Oh yeah, public keys.
So so now we go copy this value and then go into extrinsics, select Charlie, and select the session module over here, and this is the set keys, and then we paste that value over here. Now the proof is not needed because it's not being used right now. It's a optional parameter here, but all we need is this. And now if we send this particular extrinsic, bad proof, really? This was not.
This, Gautam, this is something that I ran into when I was doing the similar code before. I think you might have to override a type, like in settings developer.
This is what it is.
Oh yeah, maybe it was just keys was the type we needed.
So let's try this. So here it is 4 by default. And what I will do in our case is 2.
Okay.
There. And now, hopefully, it should work. Extrinsics. I can just copy this value. Yep, now it works.
That looks better.
So now we have, okay, so session keys are set. And now what we have to do is from Alice's account, because she is the root, we have to add Charlie as a validator. So we'll go through the root privileges and then go to validator set, add validator Charlie, and submit transaction. So it has added, the session has been rotated, and now it should produce blocks. Come on, Charlie, you can do that.
He also has to wait for his slot still, because it might be like Alice,
Yep.
Bob, Charlie, Alice, Bob.
There we go. There we go.
That's cool, man.
Yeah. So so Charlie is producing blocks. He's an equal now. And yeah, so
that started a new session. Is that right?
Yes. So like you can see that Grandpa has said that the set has changed to new set, and it has 3 validators in it now. So yeah, session.
Oh, I never saw that log item before. Does that always come out of the node template?
I haven't seen that before as well, to be honest, but I just saw that and I pointed it out.
Yeah, cool.
Yeah. Okay. So yeah, it's yeah. So that was pretty much it that I wanted to show, primarily from the permissioning side of things. Yeah, but feel free to ask me if you have any questions.
No, it's great. Learned a bunch of new things.
Yeah. Cool. Thanks, Gautam. I might hit you up shortly, Gautam, about whether you're interested in getting some of that code in the recipes too. This is a useful thing that a lot of people might like to see.
Absolutely. I think especially the part where how we use SignedExtension.
Yeah, exactly.
The second part is what all traits we have to implement for using session. I think definitely.
Cool. Okay, great. I guess we can end here. We're right on time. So Thanks
Awesome.
everybody for coming. Thanks especially to Gautam for writing all that code and showing it and doing the demo and everything. Really appreciate it.
Yeah, thanks, Gautam.
All right. See
Thanks,
everybody.
Joshi.
Yep.
Yeah.
See you.